Shri Gurubhyo Namaha, children. Welcome to our online teaching academy, Ekalaiva. Exercise 9.3 in sequences and series chapter. 22nd question. If the pth, qth and rth terms of a GP are A, B and C respectively, prove that A power Q minus R into B power R minus P into C power P minus Q is equal to 1. So the pth, qth and rth term of the GP are given as A, B and C respectively. Let us take the first term as capital A. Let A be the first term of the GP. Let A be the first term of the GP and capital R be the common ratio. Why I am using capital A and capital R? Because already there is a small a and small r over here. Okay. So I have taken the first term of the GP as capital A and the common ratio as capital R. So as per the question, the pth term is given as A. That is AP is given as A. So how do you write AP? A R power P minus 1 is given as A. And qth term is given as B. So AQ is given as B. How do you write AQ? A R power Q minus 1 is equal to B. And rth term is given as C. That is AR is given as C. How do you write AR? AR power A into R power R minus 1 is equal to C. And what are you supposed to prove? A power Q minus R into B power R minus P into C power P minus Q is equal to 1. So let us take the LHS A power Q minus R into B power R minus P into C power P minus Q. So that is equal to, what is A? Capital A into R power P minus 1, the whole power Q minus R into, what is B? A into R power Q minus 1, the whole power R minus P into, what is C? A R power R minus 1. So C power P minus Q. So here also power P minus Q. So here it is in the form of AB the whole power M. How do you write AB the whole power M? It can be written as A power M into B power M. So here also A into R into P, A R power P minus 1 into Q minus R can be written as A power Q minus R into R power P minus 1 into Q minus R. Again here A into R power Q minus 1 the whole power R minus P can be written as A power R minus P into R power Q minus 1 into R minus P. Similarly, this can be written as A power P minus Q into R power R minus 1 into P minus Q. Right? So now let us multiply the R powers, that is equal to A power Q minus R into R power. Multiply this P minus 1 into Q minus R. So you get PQ minus PR minus Q plus R into A power R minus P into R power, again Q minus 1 into R minus P. If you multiply, you get QR minus QP minus R plus P into A power P minus Q into R power. Again R minus 1 into P minus Q. If you multiply, you get RP minus RQ minus P plus Q. Now there is a base A in 3 places. So A into A with different powers. So you know A power M into B power, sorry, A power M into A power N is nothing but A power M plus N. So here the bases are same. So I have to add the power. So A power Q minus R plus R minus P plus P minus Q. So I have taken all the A bases separately. Now the R bases. So here again A power M and A power N is A power M plus N. So R power PQ minus PR minus Q plus R plus QR minus QP minus R plus P plus Rp minus Rq minus P plus Q. Here you see powers Q minus Q gets cancelled, minus R plus R gets cancelled, minus P plus P gets cancelled. Here again PQ minus PQ minus PR plus PR minus Q, here there is plus Q plus R minus R, QR minus QR plus P minus P. So all the powers gets cancelled. So all the powers gets cancelled. So it is A power, nothing is there, which means power 0 into R power, nothing is there, so it is again 0. You know anything for 0 is 1. 1 into 1 is nothing but 1. And what is that you are supposed to prove? A power Q minus R into B power R minus P into C power P minus Q is equal to 1. That is what we got it here. That is nothing but your RHS. So we have proved LHS is equal to RHS. So we have proved LHS is equal to RHS. Is it clear, children? Let us move on to the next sum. The 23rd question. What is given? If the first and the nth term of a GP are A and B respectively, and if P is the product of n terms, prove that P squared is equal to AB the whole power n. So what is given? First and nth term of the GP are A and B respectively. So the first term is given as A and the nth term is given as B. So what is the first term? First term is A1. So A1 is given as A and the nth term is AN, that is given as B. And how do you write AN? A R power n minus 1 is equal to B. Okay, so the first term is A and the nth term is B. So nth term is written as A R power n minus 1, that is equal to B. P is the product of n terms. P is the product of n terms. So what is given? P is the product of n terms. Product of n term is A1 into A2 into A3, etc. up to AN. What is first term A? How do you write A2? That is AR. How do you write A3? AR squared, etc. up to. How do you write AN? AR power n minus 1. Now here A is multiplied how many times? N times. 1, 2, 3 up to n terms. So A is multiplied n times. So it is A power n into R power. Here the bases are same. R is the base. So 1 plus 2 etc. up to n minus 1. So R power 1 plus 2 plus 3 etc. up to n minus 1. So it is A power n into R power. Here 1 plus 2 plus 3 etc. up to n minus 1 is nothing but sum of n minus 1 natural numbers. Sum of first n minus 1 natural numbers. So how do you write sum of first n natural numbers? Sum of first n natural number is given as n into n plus 1 by 2. But here it is sum of first n minus 1 natural number. So that is given as n minus 1 into n minus 1 plus 1 by 2. So minus 1 plus 1 gets cancelled. So it is n into n minus 1 by 2. So what is the sum of first n minus 1 natural numbers? It is n into n minus 1 by 2. So in the place of 1 plus 2, 2 plus 3, etc. up to n minus 1, what I am going to write? N into n minus 1 by 2. So this is nothing but your P. But what is supposed to prove? P squared is equal to A, B the whole power n. So I want P squared. So let me take LHS P squared. So I am squaring this on both the sides. So when I square P, it becomes P squared. So when I square this, it is A power n into R power n into n minus 1 by 2, the whole squared. So what happens? It is A power A into B the whole power m. So powers will be multiplied separately. So A power n the whole power 2 into R power n into n minus 1 by 2 into 2. So this 2 and 2 gets cancelled. So you get A power 2n into R power n into n minus 1. So A power 2n can be written as A power n into A power n into R power n into n minus 1. Right? So now let me continue this. Let me continue this by writing it as is equal to a power n, a into r power n minus 1, the whole power n. Okay, all these n powers I have taken it outside, commonly outside. So a into r power n minus 1, the whole power n. So this is nothing but your first term a, and this is a r power n minus 1 is nothing but your b. This a is nothing but the first term a, right? And a r power n minus 1 is nothing but your b. So a b the whole power n. So we have proved p squared is equal to a b the whole power n. So LHS is equal to RHS. So hence proved p squared is equal to a b the whole power n. Hope it's clear. Let me continue with the next question. The 24th question. Show that the ratio of the sum of first n terms of a GP to the sum of terms from n plus 1th to 2nth term is 1 by r power n. The ratio of the sum of first n terms of the GP, ratio of the sum of first n terms of the GP to the sum of terms from n plus 1th to 2nth term is 1 by r power n. So to prove this, let me first write what is sum of first n terms. So what is Sn? Sn in GP, Sn is equal to a into r power n minus 1 by r minus 1. This is sum of first n terms of the GP. What is the next one? Sum of terms from n plus 1 to 2nth term. Sum of terms from n plus 1 to 2nth term. That is given by 2nth term. That is sum of the terms from n plus 1 to 2nth term is sum of 2nth term minus sum of nth term. From the 2nth terms, if you subtract the first from the sum of first 2nth term, if you subtract the sum of first n terms, you will get the sum of terms from n plus 1 to 2nth term. Let me repeat again. Sum of the terms from n plus 1 to 2nth term is nothing but sum of the first 2nth term minus sum of the first n terms. So from the sum of 2n terms, if you subtract sum of the first 2n terms, if you subtract the first sum of first n terms, you will get from n plus 1 to 2nth term. So how do you write S2n? That is a into r power 2n minus 1 by r minus 1 minus, how do you write Sn? A into r power n minus 1 by r minus 1. Since the denominators are same, let me write the numerator separately. A is common, so a into r power 2n minus 1 minus r power n. Minus into minus 1 is plus 1. Okay, denominators are same. In the numerator a is common, so I have taken a common, r power 2n minus 1 minus into r power n minus r power n minus into minus 1 plus 1, and minus 1 plus 1 gets cancelled. So it is a into r power 2n minus r power n by r minus 1. Okay, so how do you write this? A into r power 2n can be written as r power n into r power n minus r power n by r minus 1. So here again r power n is common. So a into r power n into, if I take r power n, what is left out here? R power n minus 1 by r minus 1. So this is the sum of first n plus 1 to 2nth term. Now we are to show the ratio of the sum of first n terms of the GP to the sum of terms from n plus 1 to 2nth term is 1 by r power n. So sum of ratio. So sum of first n terms of the GP by ratio. So we have to write by sum of terms from n plus 1th to 2nth term of the GP. That is sum of first n terms of the GP is nothing but a into r power n minus 1 by r minus 1 divided by what we found here, a r power n into r power n minus 1 by r minus 1. So the numerator r power n minus 1, r power n minus 1 gets cancelled. Denominator r minus 1, r minus 1 gets cancelled, and the numerator a also gets cancelled. So what is left out in the numerator? 1 by r power n. So we have proved the sum of first n terms of the GP by sum of terms from n plus 1 to 2n the term of the GP as 1 by r power n. Hence we have proved what is to be proved. Hope it's clear, children. Let me move on to the next one. The 25th question. If A, B, C and D are in GP, show that A squared plus B squared plus C squared into B squared plus C squared plus D squared is equal to AB plus BC plus CD the whole square. What is given? A, B, C and D are in GP. So A, B, C and D are in GP, which means you know B squared is equal to AC, B squared is equal to AC, C squared is equal to BD and AD is equal to BC. AD is equal to BC. Let me mark this as equation number 1, this as equation number 2 and this as equation number 3. So ABC is in GP. So B squared is equal to AC, that I have taken as equation number 1. BCD is in GP. So C squared is equal to BD, that I have taken as equation number 2. A, B, C, D, all the 4 are in GP. So AD is equal to BC. Sorry. It is AD is equal to BC, that I have taken as equation number 3. I have to prove A squared plus B squared plus C squared into B squared plus C squared plus D squared is equal to AB plus BC plus CD the whole square. So to prove this, I'll take the RHS first. What is the RHS? AB plus BC plus CD the whole square. So it is AB plus, in the place of BC, I'm going to replace with AD. In the place of BC, I'm going to replace with AD from equation number 3. So AD plus CD the whole square using third equation or from the third equation. Then AB plus in AD and CD I have D common, so I take the D common. So AB plus D into A plus C the whole square. In the AD and CD what I took common? D I took common, so A plus C the whole square. Now it is in the form of A plus B the whole square. How do you expand A plus B the whole square? A square plus 2AB plus B square. So A square plus 2AB. So 2ABD into A plus C plus B squared. So plus D squared into A plus C the whole square. So it is A squared B squared. And I multiply 2ABD with A. So I get 2A squared BD. Then 2ABCD plus D squared into, this is again in the form of A plus B the whole square. I write it as A squared plus 2AB, that is A squared plus 2AC plus C squared. So it is A squared B squared plus 2A squared, and in the place of BD I am going to replace with C squared from equation number 2 plus 2, this AD I am going to replace with BC. So BC into BC becomes B squared C squared. Then I multiply this D squared with A squared, so A squared D squared plus 2AC D squared plus C squared D squared. I used equation number 2 as well as 3. So from 2 and 3. That is equal to A squared B squared. And this 2A squared C squared, I am writing it as A squared C squared plus A squared C squared. Similarly, 2b squared c squared, I am writing it as b squared c squared plus b squared c squared plus a squared d squared plus 2. That AC I am going to replace with b squared from equation 1. So b squared d squared plus c squared d squared. So here I use equation number 1. So again, why we do all this? Because we want to prove certain things, right? So that is equal to a squared b squared plus, now this a squared c squared I replace with b squared into b squared. AC is a squared c squared. AC is nothing but b squared. So a squared b squared, a squared c squared can be written as b squared into b squared. A squared c squared is nothing but AC the whole square. So b squared the whole square is b squared into b squared plus a squared c squared. B squared c squared, you have it as it is, both the b squared c squared, a squared d squared. This 2b squared d squared can be written as b squared d squared plus b squared d squared plus c squared d squared. So a squared d squared plus b squared into b squared plus a squared into c squared plus b squared into c squared plus b squared into c squared plus a squared into d squared. Again replace this bd with c squared. So bd is c squared. So b squared d squared is c squared into c squared plus b squared d squared plus c squared d squared. Now take these terms which has a squared. Here a squared b squared, here a squared c squared, and here a squared d squared. So I take the a squared common. So I get b squared plus c squared plus d squared. Then I take these b squared terms 1, 2, and 3. So whatever I take this, so b squared into the first a squared b squared, a squared c squared, and a squared d squared. I took a squared common, so b squared plus c squared plus d squared. Now I am taking all the b squared terms, 3 terms. And that I take b squared common, so I get here b squared plus c squared plus d squared. Then what are the things left out? What are the things left out here? So you have b squared c squared, c squared c squared, c squared d squared. In all these 3 terms, what is common? C squared is common. So if I take c squared common, b squared plus c squared plus d squared. Now you will find here b squared plus c squared plus d squared common. In all these 3 terms, you will find b squared plus c squared plus d squared common. So I take the b squared plus c squared plus d squared common outside. So what is left out here? A squared plus b squared plus c squared. So this is nothing but your LHS. So AB plus BC plus CD the whole square is proved to be b squared plus c squared plus d squared into a squared plus b squared plus c squared. So we have proved LHS is equal to RHS. Hope it's clear, children. To get our online lessons, please click the subscribe button to get the latest updates.